div 6 here, and it looks like I've got AI 0 and AI 1 by looking at them. I'm going to just control to get that second one. I have 2 of them there. Okay, I got 2 ranges, and I'm going to go the ranges from 10 volts to 0, because they don't need to go negative, differential, right? We are going to continuously sample. We essentially always continuously sample. I'm going to take, let's take, 1,000 samples at a rate of 5 kHz. Okay? And what am I doing here? I'm configuring my data acquisition device, right? The inputs are going to range from 0, and that'll only do input 0. I'm going to do input 1 the same way. It goes from 10 to 0, assuming I hooked it up right. Now, one of the things I can do is I can actually run this particular point in time, see what I'm actually getting here, and it looks like I have a couple of signals there, right? They don't look all that great, but it looks like I have a couple of signals. I have one at about 5.8 volts and one at about 6 volts, which together add up to something pretty close to 12 volts, which means I'm not dropping a whole heck of a lot on the other one. I hope I didn't do anything terribly stupid here, but let's go see what happens if we heat this darn thing up. And what we do is I put my fingers on it. It looks like one gets bigger and one gets smaller. Okay? Which means that I let go of it, and what happens is they start coming back together. Right? Are they creeping down?
Yeah, looks like it.
Pretty slow here, aren't they? Now they're creeping down a little faster, right? Because I'm trying to move them around in the air a little bit here, right? A little more convective cooling. If I put my fingers back on them again, do they go back up again?
Yeah.
Yep, okay. So it looks like I'm getting signals, right? One's going up, one's going down. That's kind of what we ought to expect, right? And they look like within the range. So I think things are working, not that I can tell it. So I'm going to say okay here. It's going to give me the do I want this in a loop routine, which I'm going to say yes. Okay, please do things for me, right? And then of course, because you're used to this game now, what do? We go make the loop big.
What's the button? Yeah.
Okay. Right, because we like lots of room. And I'm going to drag this guy up here out of the way. So, okay, now I've got 2 channels of data, right? And I need to calculate the resistance. So let me go ahead and I can erase all of my mess over here now, right? Which is just playing with the range of values. And if I wanted to, and to asking Brian's question, or that he phrased a little bit ago, is could I put some, say, indicators in there that would indicate if the voltage got up close to 10 volts? And the answer is, well, yes, of course you can. There's all kinds of fun and games you can do in there, right? So you could, of course, go in there and put something in there that would say, hey, if it gets up close to 10 volts, bellow out, right, or do something differently. Okay. So, okay, but what we're going to do here is we get some data, and it looks like what I have to do is, let's see, if I want the resistance of the therm as the thing that I want to measure, because that's the thing that's changing, right? So R of the therm is equal to V of the therm over I, right? And I is going to be equal to, well, it's VR over RR, right? So this is going to be equal to V of the therm over V of the resistor over the resistor. Okay, does that make some sense? Right, and that's gonna give us some resistance. Just playing with Ohm's law. So we need to do this bit of mathematics, right? Because right now all we have is voltages, and frankly, while the voltages are cool and they're going up and down and all that other nice stuff, they're not telling me anything, right? I want to measure resistance. So, okay, let's look at this. So what do I need to do? Well, I need to start working on these guys, right? And the first thing I typically need to do is I have a thing with two channels, right? I have two channels of information. I have V of the firm and I have V of the resistor. And they're combined together, right? When I get data out of this DAC assistant here, it's gonna have both of them mixed together. And so the first thing I gotta do is I gotta break them up. Okay, and the way we typically do this is that we typically, and this is one of those few cases we're going to be a little bit radical on data types. Let's just assume a data structure for these, and I'm going to assume that they're an array of data. An array. Let's say long rows of numbers. Let's say 2 rows of numbers. The first row of numbers 1,000 data points from channel 1, and the second row of numbers 1,000 data points from channel 2. And so the way we get things out of an array is you index an array, right? If you give an index, what's an index to an array? It's a location in the array. So if we go right click over in the program field, we can go to arrays, and pretty close up on the front, there's index array. Okay. What's index array is if I give it an index, it's going to give me that value. If I give it a row number, it's going to give me that row. If I give it a column number, it's going to give me that column. Now, I am making an assumption here. I'm making an assumption that the data coming out of the DAC assistant is an array, and I hate to tell you, it isn't, but that's okay. LabVIEW's cool with it. Okay, so let's take this index array, we're going to drag it out over here, and we drop it. Boom. And it looks like an index array, and I'm going to say, well, okay, I'll put it down here somewhere, and I'm going to hook it up. And when I hook it up to the data to the array, a little bit of magic occurs. And the magic occurs is that I got this funny blue thing here, right? Okay, and what the devil is that? I go, I don't know what that was. What the devil was that? Okay, and I can certainly put the help in there if I want to, but I also notice if you look around it, it has a little bit of light blue all around it. I don't know if you guys can see that. It has a little bit of light blue, and it's the same color light blue as this is up here, because it's a darn wizard thing. So if you double click on it, it pops a window. And what does the window say? It says, convert from dynamic data. So what this guy gives me over here is what LabVIEW calls dynamic data, which is this double blue wires. It's integer values, basically, with something. And you need to convert this into something else. Well, what do I want to convert it into? Well, I want to convert it into an array, right? But I actually want to I don't want it to be a 1 dimension, because that's just going to be a long string of numbers, right? And if a 1 dimension is going to have the 2 channels mixed together, and they're going to be a pain to separate, right? So what do I want? I want to, well, let's go down here. What are the options? 1 degree arrange as scalars, 1 degree arrange as scalars single channel. How about 2D array of scalars, columns are channel, 2D array of scalars, rows are channel. Either of these will work. I usually find it easier to think about the rows of data as being, but it doesn't matter. From as far as LabVIEW is concerned, we're gonna get rid of the array pretty quickly anyway. But right now we're gonna say if we 2D array of scalars, what it's gonna give us is it's gonna give us 2 a 2D array like this, right, data, except it's gonna be 1,000 data points long, because that's what we told it, right? And the top one will be channel 0, and the bottom one will be channel 1. Now, by the way, you can go to the DAC assistant and change those, but that's currently the way we have it configured. Okay, so I'm gonna go 2-degree array of scalars, kinda nice, floating point, and I'll just say okay. And then another little more magic happened, which is a little hard to see here, but my one big fat orange line, which indicated an array of a one-dimension array of floating point, turned into 2 skinny lines, which indicates a 2D array of floating point. Hard to see on this focus. Okay, so anyway, out of here I'm going to get my data, right? And now you notice that my array, index array, turned into 2 values, right? I get an index for the row and I get an index for the column, which of course I'm not gonna use because I'm just gonna separate them out. So I can, let's go get a number so I can do it. If I want a number, because I need to tell it, well, I want, let's say, row 0, right? Arrays are typically 0 indexed. Well, I need a number. Where might I find a number? Numeric.
Constant.
Hey, there's a numeric constant down here. Even a blue one, which is of course an integer, which is a nice thing to have here. Okay, and so that gives us row 0 right there. And out of this, I'm going to get a subarray, in this case a 1-degree array of things. I can do this again and get the second channel out. So I can get another index array and do that. Or if I notice that there are little spots at the top and bottom where I can drag arrows, and I can just pull that down 1, and I get another index array, right? So I get the second channel out, and I could go, I'm just gonna go copy this one, Control C, Control V, get that one copied. Again, make sure I get the row index. And in this particular case, I don't want both of them to be row 0, I want one of them to be row 1. Okay? Now, if I was real fussy about that, I'm gonna get 1,000 data points here out of this. Right? And as we saw from the image, they weren't exactly all the same. When we were looking at the DAC assistant, there was noise on it, because it's a noisy power supply, because they're cheap Chinese power supplies. Did I say that out loud? Inexpensive Asian power supplies. Okay, so am I better?
No.
No, okay, I'm working on it here, okay. Need to get politically correct here. Okay, so one of the things I think is I think it's pretty obvious to you that we don't need 5,000 temperature data points a second, right? That's kind of like, do I really want to fill my hard drive up that fast? Yeah, do I really want to fill it up that fast? No, I don't want to fill it up that fast. So what do we need to do? We need to do some data reduction. Okay, we need to get rid of some data points. But I'd like to get rid of some data points in a way that made sense. So I don't just want to throw them all away. So what kind of thing could I do to the data that would reduce the magnitude of it and yet kind of smooth it out? Well, probably the easiest thing to do is just take the average. Right? If I just averaged them, so I got 1,000 data points and say just average them. What's that going to do? It's going to reduce the volume of my data by a factor of 1,000, 10 to the third. That's a nice thing to do. I've done data reduction. So now instead of having to process 1,000 data points, I'm only having to process 1, right? Every 200 milliseconds, right? 0.2 of a second. So that's kind of what I like to do. Take a whole bunch of data, oversample the dickens out of it, and then what do? We smooth it all out. But if there's an oscillation in there, right, if there's a high frequency oscillation, then what's it going to do? What that average is going to do? Just make it 0, right? Just take it out, right? Because it can't oscillate that fast, right? Okay. Or pretty close to take it out. So I need something that's going to do averaging. Okay, this one, okay. Okay, now we're playing the LabVIEW where did they put it game. Okay, let's see. Any guesses?
What are we looking for again?
Something that does averaging.
Averaging.
Mathematics, okay, I can do mathematics. Okay, mathematics. It's like we got numeric, elementary, linear, fitting, interp and extract, ingret and diff, prob and stat, optimization, differential equations, geometry, polynomial, script and formula.
Script and formula. Province,
Prob and stat, I think, because mean is really what well, average is a kind of a probability thing, right? So let's probability stat.
Hey, look, me.
Yeah.
Oh, yes, there's a mean thing there. You guys should remember that, right? Mean, because doctor,
Mean.
yes, okay. Okay, so you guys should remember, right? Okay. So we can take the mean here and we drag it out and we go, okay, I have a mean thing here. I run this into this guy and out of it I get a value. Okay? And I'm even gonna I'm gonna do this twice. I'm gonna select it by just left clicking on it with the arrow, do a Control C and a Control V, so I got two of them, and and then I'm gonna take the other one and run it in over here. I got two means, I'm twice as mean, okay, and then I can go over here to my thing and get some numeric indicators, drag them out here. Make them big, because I'm blind, but you knew that. Right? And I'm gonna say, thermistor, V, how about V therm? And then we'll do it again, just because it feels good. And we're gonna call the second one V. Okay, I tried to resist it, but I couldn't. I cleaned it up a little bit. Okay, so I've got these, they appear over here. Here's my V therm and here's my V resistor. I gotta go make sure I know which one's which. It looks to me like I have channel 0 measuring the resistor and channel 1 measuring the thermistor. So I'm going to go up over here like this and down like that over there. And okay, so and I can run this into that. And then I can run this one into that. I don't really like where that sign went. We'll put it over there, just because in case you haven't noticed, I'm a bit anal about this. Okay, so what do I have? I have my data coming in. It's getting split up into the individual channels, right? So we have the data comes in over here, gets split up into the individual channels, and then what do?
Take the average.
We average them, right? We average all, so that 1,000 data points just got dropped down to one data point, and now we've done so now instead of having 5,000 samples a second, we're gonna get 5 samples a second, which is something like reasonable. I mean, it's still pretty fast for temperature, but you know, we're certainly better than 5,000, right? So that's, now, I always like to, about this time, at least for my own sense, say, well, is this actually working? So let's go ahead, I'm gonna go ahead and hit run here. And I have values, right, which look like voltages. And if I heat the darn thing up, looks like one goes down and the other one goes up, right? Which is what we were seeing on the screen, right, except now their data, right, and I let go of it and they go the opposite direction, right, so it looks like my circuit is working reasonably well, right, haven't screwed anything up yet, okay, and that's probably right, and we kind of expect that because if we remember looking at our thermistor data here, we look at